Now let's say we want to solve an inequality of this sort. This is the same as a regular inequality. The same rules apply. Adding a number throughout. So for example, negative half is less than or equal to 3a plus 4 over 2, and 3a plus 4 over 2 is less than or equal to half. So when we combine these two, we get this inequality. Now we have to solve for a, and the first thing we want to do, one at a time, we want to get rid of the numbers. But the first thing we'll do is, let's write this down, 3a plus 4 over 2 is less than or equal to half. So remember, we're looking at the middle here. We have to eventually get a by itself. But the first thing we're going to do is multiply by 2 to get rid of the 2 in the denominator. That's what we want to do. But if we multiply one side of the inequality by 2, we need to multiply the other two sides also by the exact same number. So that cancels. We get negative 1 less than or equal to 3a plus 4 less than or equal to, cancel these two, and that's a positive 1. So that's a negative 1 and this is a positive 1. So 3a plus 4 lies between negative 1 and positive 1. Now we have to get a by itself. So we've got to get rid of the plus 4. So we have negative 1 minus 4. So we're going to throughout subtract 4. So 3a plus 4 minus 4, because we want to get rid of the 4 in the expression, but we have to subtract 4 throughout the expression. Sorry, not this. It is minus 4. Notice that's a minus 4, minus 4, minus 4 throughout the expression. And when you subtract a number, the inequality or the direction of the inequality does not change. So we have minus 1 minus 4 is minus 5 less than or equal to, the plus 4 and the minus 4 cancel, and we get 3a less than or equal to 1 minus 4, which is negative 3. Now finally we're going to divide by 3 to get rid of the 3, and we divide throughout by a positive number 3, which means the inequality does not change. If it is a negative number, all these inequalities would flip to the opposite direction, but in this case it does not change. It's negative 5 over 3 less than or equal to a. Remember, we're trying to get a by itself, and now we have it, is less than or equal to negative 1. So our solution of the inequality is this. Let's graph it on the number line. 0 is in the middle, negative 5 over 3 let's say this is a negative 1, negative 5 over 3 is to the left of, it's less than negative 1. Remember, this is a less than or equal to, so put a solid dot. Let's use a different color. Less than or equal to 1, and a lies in between. So a can be any number in between or including negative 5/3 and negative 1. So this is the solution to the inequality, and we've graphed it. So this is basically the interval -5/3, comma, so that's your lower bound, and your upper bound is -1. So any number in between, so it gives you a range of values, so any number in between is part of this set, including the endpoints. These are the endpoints. This is the lower bound, and that's the upper bound of the interval. So we have a compound inequality here. There are two inequalities joined by the word or. So or is the word that goes with union, uniting the two inequalities. The word and goes with the overlap or intersection. So let's solve each inequality separately. So let's do this. Let's solve for z. So we have 5z plus 7. Remember, we are trying to get z by itself. So I'm going to subtract 7 from both sides. So that would be 5z plus 0. These two cancel each other out and you get a 0. And that gives you 5z is less than 27 minus 7, which is 20. We're going to divide both sides by the positive number 5. If you divide by the positive number 5, the direction of the inequality is unchanged. So you get 20 over 5. This doesn't change. It remains less than. 5 over 5 is a 1. 1 times z is a z, is less than. 5 goes 4 times into 20. So z is less than 4. Now let's solve the other inequality. -3z is less than or equal to 18. We want to get rid of the -3. Now you have to be careful here. It's a negative number that you're going to divide by. You're going to divide by -3 on both sides. But remember, multiplying or dividing by a negative number will change the direction of the inequality. This is something important to remember. It changes the direction from less than or equal to greater than or equal to. So we cancel the 3's, -3's, that gives us a 1. -3 over -3 is a 1. 1 times z is a z, greater than or equal to -6. So now we have z less than 4, union. The word or goes with union. Z greater than or equal to -6. So let's see what the graph looks like. So -6, let's say, is here, and let's say 4 is here. Anything less than 4, let's use a color here, strictly less than 4, so I put a circle, not a dot. It's the entire number line. So you have the interval -infinity to 4, not including 4, so use the parentheses here. It's a range of values, this purple part. That's your first set. And then the other set is greater than or equal to -6. So I'm going to put, it's possible that it's equal to. So I put a dot, and greater than or equal to, so it goes on forever to the right. Now if you combine these two, it could be either the red part or the purple part. Notice that nothing is left out other than, in fact, nothing is left out because this red part covers the one little dot that we left out here. That is 4. Now this is the entire number line. If we combine the two with the union, then we're going to get negative infinity to positive infinity. Now let's see what the intersection of these two is. What if I said z is less than 4 and, let's look at this, z is less than 4 and z is greater than or equal to negative 6. Let's see what that looks like. It has to be, the word and says it has to be the overlap of the two. So let's quickly look at it once again. Z less than 4. Let's use color. Z less than 4. Strictly less than 4. So we're going to put a circle here and then everything to the left of it. Okay. Z greater than or equal to negative 6. So I'm going to use, let's say, a blue. Negative 6, suppose, is right here. Negative 6 greater than or equal to, I'm going to put a solid dot, and everything to the right of it. It includes the 4. Everything to the right of it. But remember that we are looking at the intersection, which means the word and says intersection, the overlap. Look at the blue and the purple. And remember, the purple goes through this dot. And when you look at the two, the overlap would include the negative 6, comma, and it'll go through this entire interval, but it's not going to include the 4, right? Remember, there's a hole at 4. The purple is not part of, or rather 4 is not part of the purple. So we need to exclude the 4. So that would be the overlap. This is the overlapping region, but the endpoints, you got to be careful. What goes through the blue dot at negative 6 is the purple line and the blue line. So the negative 6 is included, but the 4 is not, because the purple doesn't go through 4. So if you're looking at the overlap, it's only this portion of it which goes from negative 6 to 4.